Hey guys, welcome back to another lecture video for Chem 104. In this lecture video, we are going to learn how to name cyclic alcohols, and we're also going to learn how to name alcohols that's found on benzene rings. And so let's go ahead and start by going through the rules for naming cyclic alcohols. And so typically when you guys are naming cyclic alcohols, all the rules that we've discussed, the foundational rules, such as like finding the parent chain and numbering them, and creating a number system so that the lowest carbon number is on the alcohol, etc., etc. All of that still applies. The only difference is that since the substance that we're naming is a ring, wherever the alcohol, whatever carbon that alcohol is located on, that's always going to be carbon number one. And so for this example, notice that my alcohol is positioned in the top right corner of that cyclic ring, if you will. And so that carbon number is always going to be carbon number one. And so because it's always carbon number one, you're going to omit this number from the name of the alcohol. And so you don't have to say, cyclopentane or cyclopentane-1-all. You just say cyclopentanol. And so once again, the point of difference is the fact that these structures are cyclic. And so once you've made alcohol as your priority, once you've made alcohol as your priority in your numbering system for a cyclic compound, whatever carbon that alcohol is attached to, that alcohol will always be carbon number one. And so the ring is numbered to give, the next substituent the lower number. Okay. And so we're going to have to kind of play around here for some molecules. We're going to have to go clockwise, counterclockwise. And so we'll go through a couple of examples just so that you can see what I'm talking about. I'm going to represent blue going in clockwise. So if this is number 1, this is number 2, 3, 4, 5, 6. Okay. Now if I go counterclockwise, I'm going to use green as my counterclockwise. It's going to go 1, then 2, then 3, 4, 5, 6. And so if you guys are looking at this methyl group, and this methyl group is going to represent my substituent because it's not it's not embedded in my parent chain. Notice that you have two different numbering systems, 5 and 3. And so you guys are going to choose the number that's the least. And so therefore, I'm going to go ahead and erase all of the numbers in blue. And so this is telling me that I have on carbon 3 a methyl group. So I'm going to say 3-methyl. Okay. In terms of naming your parent chain, notice that there's 6 carbons. So 1, 2, 3, 4, 5, 6 carbons. So this is going to be, So since this is a cyclic alkane, I'll have to say cyclo. Okay. So cyclo is the cyclic part. Cyclohexane would be the normal way for me to write this if there was no alcohol. But since there is an alcohol, I'm going to drop the E and I'm going to add the OL. So this is going to be cyclohexanol. And since 1 is going to be omitted In other words, we're not going to include it in our nomenclature. We don't have to separate this all. All right, so we don't have to do, let me see if, let me erase this. So in the previous lecture, if this was like a double bond, we would have to be like 1-OL or something like that, right? And so here in this case, we're going to ignore all of that and just simply put in cyclohexanol. It's implied that this alcohol is on carbon 1. Okay. And so after that, all we do is just name or add in our substituent. Here in this case, it's 3-methyl. And so since you're going from letter to letter, we can go ahead and kind of scoot these two guys over and just say 3-methyl cyclohexanol. And we're done. And so here we have carbon 1. So we have 1, 2, 3, 4, 5. So we have a 5-carbon ring. So we're going to go ahead and use cyclopent. And so since there's no double bond or triple bond in the ring, we're going to say cyclopentane. Since we have the presence of an alcohol, we're going to go ahead and erase the E, add in the OL. And since this is a ring, we don't need to put the number 1 in our nomenclature. And so we just need to figure out our numbering system. And so I'm going to represent blue as clockwise. So 1 is here, then this is 2, 3, 4, 5. And if I go counterclockwise, I have 1, 2, 3, 4, 5. And so looking at the two different numbering systems, notice that 2 is less than 5. So therefore, the counterclockwise numbering system for this example is incorrect. And so overall, it looks like I have a 1,2-carbon substituent. So that's ethyl on carbon 2. So I'm going to put in 2-ethyl. So I'm just going to go ahead and attach that to the very front of the parent name. So I have 2-ethyl cyclopentanol. So since I'm going from letter to letter, L to C, I'm just going to go ahead and put in one word, no dash, no comma. Okay. And so once again, the number 1 that represents the alcohol is omitted. Oops. All right, so let's go ahead and take a look at a couple more examples here. And so let's just go ahead and take a look at this example on the right. And so once again, here we see a cyclic ring with an alcohol. So we just need to count the number of carbons. So 1, 2, 3, 4, 5, 6. And so here we have 6 carbons. And so we know that this is going to be a cyclo, hex, and then here there's no double bond. So this is just, I don't know what that is. So ignore that. That's not a double bond. So that's cyclohexane. And so since I do have the alcohol, I'm going to drop the E and put in cyclo cyclohexanol. Okay. And so since this is a cyclic ring, I don't need to describe the carbon number of the alcohol. And the only thing I need to describe is the position of my substituent. And so since the alcohol, whatever carbon it's attached to, is always carbon number 1, and since I only have one substituent in this scenario, then I have a number 1 for my methyl. And so I'm just going to go ahead and complete this naming of this organic compound by writing 1-methyl cyclohexanol. One word. Okay. And once again, the 1 that's typically between the methyl and the cyclohexanol is ignored. So the 1 is omitted. And that 1 was supposed to describe the position of the alcohol. Okay. For cyclic rings, we know that the alcohols always get carbon number 1. All right, so we're going to go ahead and look at another example. And so this time we have a double bond. Okay. So same scenario, we have an alcohol and a methyl group, but now we have a double bond. So how would we incorporate that double bond in our naming scheme? Well, since there's an alcohol on a cyclic ring, we know this is carbon number 1. And if we count the number of vertices, if you will, this is carbon number 2, 3, 4, 5, 6. So it looks like I have 6 carbons. So once again, I'm going to put in hex to represent my carbon number. And since it's a ring, I'm going to put cyclo. So this is cyclohex. Now, since I have the presence of a double bond, I can't say cyclohexane. I have to automatically say cyclohexene. And I'm going to go ahead and erase this E, and I'm going to add OL to represent the alcohol. So this is cyclohexanol. And so you need to communicate to the reader what carbon number this double bond will start. So we need to figure out our numbering system. And so if I use blue to go clockwise, I have 1, 2, 3, 4, 5, 6. If I use green and go counterclockwise, I have 1, 2, 3, 4, 5, 6. And so if I go counterclockwise, carbon number 5 is where my double bond will start. If I go clockwise, carbon number 2 is where my double bond will start. And so since 2 is less than 5, my numbering system in green is wrong. And so I will have to communicate to the reader that this ene, this double bond, is going to start at carbon number 2. Okay. And once again, the number 1 that's supposed to be wedged between the ene and the all is going to be ignored or omitted. Okay. Once again, it's ignored because we have a cyclic ring. If we do not have a cyclic ring, then we have to wedge that 1 in between the ene and the all. So finally, we're going to go ahead and describe the position of our methyl group, and that's going to be on the first carbon. And so we're going to say 1-methyl dash 2-cyclohexenol. This 2 is representing the carbon position of where the double bond starts. Okay. So let's go ahead and look at another example. So here, we know that this is carbon number 1. And it has the same carbon number as the previous two examples. So I already know that this is going to be a cyclohex. Okay. So cyclo represents the ring. The hex represents the carbon number. Since I have a double bond that's present, I'm going to put cyclohexene. However, I have an alcohol, so I need to erase the E and write OL. And since I know that this alcohol is going to represent carbon number 1, I do not need to separate the ene and the ol, so I don't need to put in -1-ol like you saw in the previous lecture video. And so I'm just going to go ahead and remove this and combine these together. Okay. So you can only do this for cyclic compounds. However, I still need to describe the position of my double bond, and I need to describe the carbon number for my methyl. And so since the next carbon over, if I go clockwise, is carbon number 2, it would probably make sense to number my carbons clockwise. And so it looks like on carbon number 2 is where my double bond is going to start. So I'm going to put in 2-cyclohexenol. And so I need to describe my substituent, which is going to be 2-methyl. And so putting these pieces together, I have 2-methyl dash 2-cyclohexenol. Okay. All right. And so let's go ahead and do, let's go ahead and do both of these examples. Yeah, let's just do it very quickly before we go through the benzene stuff. All right, so here I have a 6-carbon ring, so I know that's cyclo. Hex. Now if you look, there's no double bond. So no double bond, it means cyclohexane. So we're going to go ahead, since the alcohol is found, we know that this is carbon number 1, and we're going to erase the E and add the ol. So hexanol, cyclohexanol. And so if I number my carbons clockwise, I'm going to get a value that's going to be lower than if I were to number it counterclockwise. Okay. And so here I have 2 methyl groups. They're both on carbon 3 on the ring. So I'm going to say 3,3-dimethyl. And so I don't need to put a number to describe where that alcohol is located because it's implied in a ring that's always carbon 1. So I'm just going to scoot the 3,3-dimethyl over. And so that way it's just one word, and that would be my final answer. This would be my final answer. All right, so looking at this structure, once again in this scenario, I have a double bond and an alcohol. And so since this is a ring, this is going to be cyclo. And so it's a 6-carbon ring, so I'm going to say cyclohex. And since I have a double bond, that means it needs to be ene. I'm going to erase the E, put an OL to represent the alcohol. I know that this is carbon number 1, and so therefore I just need to number my carbons either clockwise or counterclockwise so that the next substituent, if you will have the lowest carbon number. And so in this scenario, if I go counterclockwise, the start of my double bond will be on carbon 2. Okay. And so this is probably the most favorable numbering system if I go counterclockwise. So that's 2, 3, 4, 5, 6. And so it looks like I have on carbon number 2 a double bond. So this 2 is going to represent the location of this double bond. Let's see here. And so we just need to describe the 2 methyl groups. So since they're both on carbon number 5, we'll say 5,5 dash dimethyl. And since we're going from a letter to a number, I need to put a dash. So I'm just going to scoot this in just a little bit. Okay. And this would be the name of this organic compound. 5,5 dash dimethyl dash 2 dash cyclohexene all.